Mr. White,
Yeah.
but
Any
I'm thinking that we should change the time for this morning, Monday, 9 o'clock.
oh,
Since,
all right.
since
Once
I don't know why it ended up being Monday in the first place. There was some reason, but this Monday 9 o'clock is for this free service that I am presenting almost every week.
yes. All right. I just
I'm
enabled the
oriented.
YouTube.
No, because I'm oriented, I need to prepare. And like this weekend, like yesterday, I sleep the whole day. I'm so tired. So
All right. Hold on. Susan, I just enabled the YouTube here. All
what's
right.
that?
I just enabled the YouTube.
Oh, okay.
Yeah, I tell you, between marking and everything, man. Right.
But where's everybody? I put the reminder, and even Mr. Thomas actually had wrote and said that where's the passport?
Okay. Susan, I think the link you sent me was different, you know. You want to send back the link?
All right, let me send that.
Yeah.
Is it the link I sent you? No, it's the link you sent you. I logged on enough. But
Oh, all
oh,
right.
I logged on. But let me just check.
Right. I see.
Let me check. Um,
No, I think what happened. No,
this
I
one.
know what happened. I checked the chat between you and me. That was the one I was using.
Mhm.
All right.
Is that the one I use? Let's see if anybody else got it.
Oh yes, somebody else joined.
Who is that?
Okay, Miss Delissa joined and Mr. Logan. So
Right,
it's correct.
but it's the same link they're using. So put
Yeah.
that there.
All right. All right. Morning, guys.
Good
Morning,
morning.
everyone.
Good morning, everyone.
Morning, Mrs. Delissa.
Good
Morning,
morning.
Sir Logan.
Mrs. Alyssa,
Good morning. Good morning.
welcome. Sorry that you didn't get the information about this. This is the fourth access. This is the fourth of we've actually met every week. And Dr. Thorpe was our guest speaker last week. And Dr. Facey Shaw was the primary speaker in week 2. So we're looking forward to Mr. White's um, wisdom today. Or his
Uh,
2 cents, whichever one you want to call it.
Susan, do you have the recordings from the ones that I missed?
Yes, they're all recorded. I just have people organize it. So where do you have them together? They've all been
yes,
recorded.
there.
They're all
Um,
recorded.
we could search for them. Yes, and the YouTube. We have the YouTube links.
Right. So
Yeah,
they're
if you
all
can
on.
put the links. Yeah, I'll
Right.
appreciate the links.
Apart from the first week, I don't think we did the first week on YouTube, did we? I think the first week was a Zoom call, but from week 2 we've actually been there's a YouTube link so you can it's private, so you can actually watch it on YouTube.
I'd love to do that. Thank you.
Good morning, Derek and Dwight.
Good morning.
I don't know if we should be looking for a higher number. I know Mrs. McNamara was stating that there was that the people who need to be here are not here. But I would think that Mr. Banta, as a new lecturer, is here. And we've typically had as many as 20 persons on this every week. So I'm still wondering where is people today.
Oh, I'm sorry. Sorry about that. All right. Morning, Mr. Thomas and Mr. Ezzy.
Well, I'm going to put a reminder in even though the skit uncensored group is not all staff.
All right, morning, Dr. Shaw.
Morning.
Oh, yes, I was wondering.
Well, I had clicked on the second link, but it apparently didn't work. It was waiting. The second link that you sent after the way it said meeting ID and password missing, that's the one I clicked on, and
Oh,
it
that
doesn't
one
work
doesn't
because it says waiting for the whole, or the meeting started. Meeting is on the 12th of April or something of the sort. So you might want to delete that just in case people are gonna use that to try and.
Is it I can't hear you, Lisa.
I'm just saying that the second link didn't work.
Oh, the second thing.
That
David. Oh, Mr. White, could you send back the link so I can send it back on the chat? What's the right link?
The one you sent first worked, but because I saw the second link, when I went there, I was just there waiting.
Mr. Graham has a picture. I've never seen him with a picture.
Good morning. Good morning, colleagues.
Good morning, Sir Graham.
Morning.
All right,
I
Mr.
guess
Thomas got
Susan-
bounced off. Okay. All right, Susan, when you want me to start?
I'm just saying, okay. I was just, oh, okay. Maybe I should just put in the chat as the first thing, or just put back in the first thing. You think anybody else is? I don't have the passcode. It's actually it's Mr. White. Okay. I'm going to go ahead and do a 2-minute formal introduction. Good morning, colleagues. I'm happy to welcome Mr. White to present today on focusing on chapter 3, or the third stage of the all research projects, which were written up in chapter 3. I personally have been very impressed and influenced by the way in which Mr. White has really had an impact on the students' ability to do development and research. And David, maybe you don't know this, part of why I'm doing this and why initiative I'm about to do is because I see that you're doing something, and it makes me realize that even more can be done. I'm quite influenced by your current initiative. And as such, I'm looking forward to your presentation just now. And let us welcome Mr. David Wright, Program Director of PSC Computing.
All right, thank you, Ms. Muir, and thank you for those warm words. I was looking around to see if you were talking about somebody else. All right, good morning, colleagues, and welcome to this series that Ms. Muir has started. And I've learned a lot. I mean, some of this stuff I learned before. But the nice thing about research, you see, is that research begets research. So the more you conduct research, the more you work in the area, it's the more, that you meet people of like minds, and you, you improve on what you knew before. All right, so I'm hoping today, right, I've no doubt you know some of it already, but I'm hoping today that I can add some value. All right. Okay, let's get
Mrs. Mamara says she's waiting to be looked at in. Maybe she's on the wrong.
I think she's on the wrong link. Okay.
Yeah, morning. I was having trouble with the link that was sent most recently as well. I had to go back to one of the older emails.
Yes, that's what I was telling Susan.
Oh, so is the one in the chat the right meeting link?
Just delete the second one, Susan, that you had sent, so people will go back to the first one.
Okay.
Susan, the passcode. Oh, let me put it in the meeting chat. I'd sent the passcode to Susan directly. Okay. So Thomas, can you post it in the BSC link too? Right, the one, not the uncensored. I think Susan posted it in the uncensored, the other one. Oh, it posts already. Okay. All right, thank you. All right, so good morning again, colleagues. Let me share my screen. All right, so the presentation is really about chapter 3, and Ms. Muir had asked me to look on how to do research and mini development projects. So here goes. Research and mini development projects, right, involve a major project with a research-based component. Somebody's mic, who that is, or is Susan? All right. Yes, so it involves a research-based component, and it involves development of some artifact. And my colleagues and I were debating just just how exactly we define artifact. There needs to be some clarity there. But in general, the mini development projects involve the development of a research-based component and the development of an artifact. And we define the artifact as, an app or a prototype of a program or software system, right? And it's intricately tied to the research-based component. We were debating as to whether or not the artifact could also be, if it's a research-only project, it could be the results of the study, right? Probably a hypothesis, probably a new theory, probably a new formula, right? A cause and effect formula. All right. It could be a model, all right? But I know in SCIT we tend, when we look at research and mini development, to look at some software component, but it is not. The point I'm trying to make it is not limited to that. All right. And I just put a note there for the newcomers that other major project types include large development and research only. So there are 3 types we have, right? Students can choose to do research and mini development, which is what I'm presenting on today, but you can also do large development and research only. Now, this is a document I got from UTech. I didn't see a date on it, but it was entitled Structure of the Major Project Report here in SCIT. And it outlines, this was given to students, it outlines essentially the 5-chapter model using the APA format. And if I focus just on the methodology section, notice it says here, and I'm quoting, in the methodology, you should identify the materials and components need to carry out the test. List the drawing and circuit diagrams, identify and discuss all the special testing equipment and processes used in the project. It's general, I guess it's for all of UTech. So they mentioned drawings and circuit diagrams, identify the variables, how they limit the project and how they will be controlled. I'll talk about variables later, dependent and independent. Here's another take on it. This one is from the dissertation guide from Nova Southeastern University, 2006. And again, it outlines the 5-chapter model. And if I just zero in on the methodology chapter, I've summarized the ingredients. It says that in the methodology chapter 3, right, you should outline the research method or methods employed, because later on I'll talk about mixed methods, right? The specific procedures that you employed to conduct the research. And then the 3 last things, and looking at major projects over the years, sometimes in the mini Viva, a number of persons seem to forget that those three last ingredients are very important, right? One, so everybody knows you have to spell out, you know, the research methods and what you're going to do, but you also have to talk about the format for presenting the results, right? How will you store the results and how will they be presented? Will it be graphical? Will it be tabular? You know, will it be descriptive? And what were the resources that you use? Now, this is important to see, colleagues, because research, as you'll see me hear me mention in a later slide when I'm drilling down to the specifics, research should be replicatable, right? As part of the validity, if you claim that, you know, you did A, B, and C, and you found as results D and E, then somebody should be able to follow your methodology and pretty much get the same results that you did, right? But they won't be able to do that unless you spell out, right, what equipment you use, what software you use, and so on, right? I'm going to show you an actual um, um, major project that I supervise, one that what came through the Intelligent Systems Lab, right? And finally, like all chapters, you're supposed to have a summary. Every chapter in your thesis document should have a summary. And of course, chapter 5 is a summary of all the summaries, right? And it's very good because then you can, that will also help you, right? To do the abstract later on. But remember, every chapter must summarize what you just presented. All right. Now, chapter 3, the research methodology, right, looks at the research design, right? What are the different types of research design? And I know for most of you, this is revision, so I'll just quickly talk about it. Research design, you see, you can classify the research methodologies according to a number of areas. And I'm going to ask some questions, and those questions will help you to zero in on the type of research design that you're going to employ. All right. So the first one I'm going to ask is, what is the contribution of the research that you are conducting? What is the intended contribution to the body of knowledge? Because remember, you know, right, we say we conduct research because there's a gap in the body of knowledge, right? So what is the contribution that your research is going to add to the body of knowledge? And based on that, they have broken down research into two main types: basic research and applied research. And I have their action, which is a special form of applied research. Now, what is basic research? Basic research, you see, you are really scurrying through the data, existing data, to see if you can add fundamental knowledge. So basic research, as opposed to applied research, where you're not just scurrying through the existing knowledge to summarize and add fundamental knowledge. In applied research, you actually offer a solution to the problem and guide decisions, later decisions. All right. What is the purpose of the research you are conducting, right? Some options are exploratory, descriptive, and casual. What is exploratory research? With exploratory research, you're trying to get preliminary information because little is known about the research area, the research problem that you identified in your chapter 1, right? So what you are doing, when you go through the literature, there isn't a lot, right, of knowledge there. So your research is pretty much, right, adding preliminary information. What is descriptive research? In descriptive research, the concepts are already known. So you now are going through and measuring the data and describing the phenomena that you notice among the data elements, right? So that is descriptive research. And finally, causal research. With causal research, the data is there, the concepts might already be known. You can browse through the data, but then what you're trying to do now with causal research is to establish a relationship or relationships right? If there are more than one, it might be multifaceted among, and later on, as I said, I'm going to talk about the dependent variables and the independent variables. So what you do is with causal research is you measure. Yeah.
It's causal, not casual.
Right, sorry, right, causal research. Thank you. Right. So what you're measuring is the causality. Thank you, Ms. Muir. Right. So you measure the relationship among the independent and dependent variables, right? And then you describe the causation. Now I want to just stop right there for a moment, right? One of the challenges we have is something I remember, a fundamental rule, and I always say to my kids, right? I say to them, in their arguments to me, I always say, hey guys, remember, correlation does not equal causation, because if it means that every time as a family we travel to so we travel to Old Harbor to go and have nice fish dinner, right? And every time we go to Old Harbor, it rains, right? All of that might just have been a random occurrence, right? We just might have been lucky. It doesn't mean that if tomorrow our weekend coming, if the government lifts the curfew, we decide to go to Old Harbor to eat fish, that it's going to rain, right? So correlation, even when you have a strong correlation, it does not necessarily mean causation. Sometimes you see, and that is why we tell students not to use words like, oh, so we have definitely proven beyond the shadow of a doubt, or it is a fact, right, that so, a program that we have written has demonstrated that so is so. No, right? And if you permit me, let me just show you something. I'm going to stop sharing that for a while. Just show you something very quickly. I use this a lot when I'm in the intelligence lab and when I'm also supervising major projects. All right, and I'm not the one who came up with it, but I liked it so much that I started using it. Right, just bringing it up in a second. All right, and this is actual factual data, right? Yeah, this is factual data. You see, that was gathered from the United States. And it was quite interesting, right? When you look at the one about cheese, second, I had it up there a while ago. Here's it. All right, it's called spurious correlations, and it was compiled by a gentleman known as Tyler Vigen. Let me share the screen. Those of you have seen me present in other forums, so me use this already. All right, so it's from www.tylervigen.com, right? And it's entitled Spurious Correlations. Sorry, you can look it up yourself, download it, or I'm hoping he has a updated version. So this look at real data from the United States Department of Statistics over a period of a decade, right? And this just underscores the point that you can have strong correlations, very strong correlations, but that does not equal necessarily causation, right? Remember, we're talking about causal research designs, right? So you can come up with some stupid, very absurd conclusions if you're not careful, right? If you don't know this concept. So here, for instance, they're looking on, this is data from the United States Office of Management and Budget, and correlated with data from the Centers for Disease Control and Prevention, the CDC, right? And what they looked was how much money the US spent on science, space, and technology over the decade from 1999 to 2009, along with data on how many persons committed suicide in the US by hanging themselves, strangulating themselves, or suffocating themselves. And what you would notice during the period is that there was a those of you who know statistics, right? And you run the various tests, you see that R equals 0.99, right? It was a 99.7 or 99.8% correlation between the two data sets, right? So every time, you know, the US spend more on science, and of course, over the period, they were spending more and more, but every time they spent more on space exploration and science and technology, right? The number of suicides went up, and it went up in just about the same level, right? Every time it leveled off, the suicides leveled off, right? And when it started to rise again in the 2000, if you notice, there was a leveling off in 2004, right? Then it started to rise again about 2007. There was a slight leveling off in 2001, then it rose again between 2003 2004, and so too did the number of suicides, right? So somebody could make a spurious conclusion that every time the US spend more money on science, right, it's going to cause more suicides to happen. And we all know that right, makes no sense. You get the point I'm making? Let me just show you a few more and then I go back to the main presentation, right? But it's very important, and you should share this with your charges, with your supervisees, right, to drive the point home. I spent quite a lot of time in some workshops with my students so that they could get the point. All right. You know Nicolas Cage, right? Famous, right? One of my favorite actors. Comes in Face Off and a couple of other movies, right? Now the number of people drowned by falling into a pool in the US correlated pretty much. It's not as strong a correlation as the one I showed before with the spending on space and the number of people who committed suicide. But there was a pretty much good correlation between the number of films per year that Nicolas Cage appeared in, right? This year he got an award, or it was last year, right? One of the top actors, you know. So he appears in quite a number of films, a successful actor. And the number of films that he appeared in seemed to correlate pretty well, right? Just about 67% with the number of people who drowned by falling into a pool. Every time they gave Nicolas Cage less movies to star in, right, the number of people who drowned fell. And every time they give him he got more roles in movies, the number of people who drowned by falling into a pool rose, right? So does that mean that if you give Nicolas Cage more movies, right, more people are going to drown in the US? Hell no, right? But it just shows you again, spurious correlation. And I could show you some more, but I'm going to, oh, no, I have to show you this one. I had cheese for breakfast this morning. The number of people who died by becoming entangled in their bedspreads, right, correlated pretty well, just about 95% with the per capita cheese consumption in the United States between the decade of 2000 and 2009. Every time you see the people ate more cheese, right, than the number of people who died in their bed sheets being entangled with it went up. And when it leveled off, so too did the deaths level off, right? And so on. You can browse through. I'll leave you to go through and look at things like, the age of Miss America, right? It's a good one too. And the murders by steam and so on, right? Quite a few one. But the takeaway I want, right, from this is that, for causal research, right, correlation does not necessarily, notice the word necessary, because sometimes it might, right, but it does not necessarily equal causation. All right, I'll go back to my main presentation.
Mr. White, could I ask a question now?
Yes, I was hoping to take the questions at the end, but
no problem.
All right, okay, all right. So let me just rush through quickly. So what are the other? Remember, I was talking about research designs, right? The research methodologies. So very quickly, how will the data? Another way you can classify this is how will the data be acquired? And this one is pretty popular when I look on major projects coming before us here in SCIT. You have qualitative and quantitative. With qualitative research design, you see, or methodology, you intend to conduct an inductive inquiry aimed primarily at understanding something like social phenomena, right? So it lends itself to a narrative based on a context-specific holistic inquiry, right? And you find out that qualitative tends to, persons doing like social psychology and so on, that kind of research, they use qualitative quite a lot. You're going to study a patient, you're going to study a phenomena, you're going to study a social situation, you're going to look at persons in their environment. A qualitative study is quite good for that. A quantitative study now, rather than being inductive, it is a deductive inquiry, right? And that should be inquiry, right? Right there, spelling, aimed at examining, it's like causal research that I spoke about, right? You're looking at cause and effect relationships, and it lends itself, you say, to statistical analysis. And if done well, right, you can extrapolate, right? The word I have here is generalizations. So you can extrapolate from the data to describe a wider the wider population. So you could even look at a sample, like a population sample, gather data or study, right? The sample, right? And then based on the deductive inquiry that you perform, you can then make generalizations about the wider population. And what it does, you see, is again a good research design. If you design it carefully, right? Then it should be a context-free inquiry dealing with individual variables, all right? And finally, in terms of the specific ones, what about the time period of the study? What is the time period? Not how long you are taking to do the study, but what is the time period, right? You're going to study, that you're going to include the data that you're looking at in your research. What's the time period that relates to that data? And the two research designs we have are cross-sectional and longitudinal. So with cross-sectional, you see, just think yesterday, I was helping to prepare dinner, and I was trying to show the kids that, oh, daddy is a good chef. I was trying to use a big knife to chop up the vegetables, like the cucumber, like chop, right? When you do that, when I take the cucumber and slice it with the knife, what I'm doing is creating a cross-section of the cucumber, the tomato, right? So with cross-sectional research, you see, what you're doing is like if you view time, Einstein said time could be looked at as a river. It's like you're looking at the river of time, and you use a knife and slice it. So you're looking at a specific time period or time frame, right? And you're going to grab the data from that time frame and use it now in your research. Longitudinal now looks at the data over a period of time. So for instance, you see, if I'm studying temperature, one of the projects I'm supervising right now is looking at temperatures in this COVID-19 pandemic, right? If we are doing a cross-sectional research, right, then we might look at data that we captured over 1 day period or so. We could study it from 9 o'clock in the morning till 9 o'clock in the night, but it would be cross-sectional for the purposes of our research, because that's just a data at a specific point in time. If, however, I'm comparing data, let's say I'm comparing the average temperature, another project, another supervisor sent his group to us, and we were looking at the data for that group. I think it was Mr. Clark, Roland Clark. They're looking on rainfall. So what happened now, I introduced them to a longitudinal set of data where they could look at rainfall in the 1960s. Then they look at the rainfall, the average rainfall in the 1970s, and so on and so on. And we look at what was happening in each specific year. Was there a drought this year? Was there a landmark hurricane season? You follow? So longitudinal looks at this data over a period of time. And I know a period of time might be subjective, right? Because a period of time, depending on the context, right? My day, when I said that my data is cross-sectional for my temperature, automated temperature group, right? If it is that you're doing some other thing. Probably you're looking at radioactive decay. Are you looking at something that decays like in seconds? Then looking at the data over a whole day, right, might be longitudinal for you, right? But cross-sectional in general looks at dealing with the data over a short period of time or a specific point in time, whereas longitudinal looks at it over a relatively longer period of time, right? And finally, well, I said that was finally, right? So the last one is mixed methods, where you employ now a combination of the research method. So for instance, you could employ like a combination of qualitative and quantitative. All right. Now, just going to switch gears a little to wrap up. What are some of the others? The rest of the research is for another time. I was looking at the rubric. I'm just going to talk now about some specific things and then show you an example, actual research that I supervised. All right. Now, remember in the research design, we spoke about, spelling out exactly what you are going to do. So what happens is you have to measure, right? I spoke about the variables. Measurement is an important factor in your research, right? What exactly is measurement? Measurement is really looking on pieces of observable information. It limits the data, right? Things like, in my case, we're measuring the temperature. We're looking at the temperature. We look at the temperature readings. I also might want to measure the distance at which the temperature sensor is, the angle, right, at which it is, and so on. The quality. I might look at we're using a camera, so I might look at the sharpness of the camera, right, the lumens and so on, right. So measurement, the concept of measurement, right, or the process of formulating and clarifying concepts, right, into measurable variables is called conceptualization. Now, just want to tell you quickly, I spoke about independent variables and dependent variables and constants. With a constant, to say the constant doesn't change over time, right? With a variable, as the name implies, the specific measured value that it contains might change. So with a constant, when you measure it, it will be the same over and over and over. Last night, my son and I were looking at something, and we were we discovered a certain constant, right, among the data we were looking at. So we had our eureka moment. The speed of light is a constant. So the data doesn't change over time. There are other pieces of data that you measure, like for instance, the temperature, right? That will change. That may change over time. All right. Now you have independent variables and dependent variables. The dependent variable, in a nutshell, I'm trying to cut it short. The dependent variables, right, influence the independent variables. So if there's a causal relationship, when you measure the data, right, and the correlation, and of course other factors, you might notice that there's a correlation between the dependent variable and the independent variable. But how are you going to establish that it is not just a spurious correlation, as I showed a while ago in that other slide that I'd put up, right? That is where now your research design might involve you now. Sorry, a while ago, let me just repeat. The independent variables influences, right, the dependent variable. You follow? Right? So what you might do now in your research design is you deliberately, right, change the values of the independent variables and observe or measure, right, the value of the dependent variable. And if every time again, it comes to your research design, but if you design it in such a way, that the variations are really significant, right? then you can establish not if there is more than just a correlation, but actually a causal relationship, meaning no matter how varied the independent variable is, or the data that you put in there is, you always see a predictable change, right, in the dependent variable, right? So if A influences B, right, A would be the independent variable and B would be the dependent variable. And then I set A, you have a range, and let's say I set A to, let's say B, just for purposes of discussion, B is always twice what A is. Then if I put A as 2, you should see B doubling. If I now put A as 100, you should see the same effect. If I now put it as 100 billion, which is what I tell my students sometimes, say, look, don't come to me, right, with 1 or 2 or 10 measurements, right? But we have to do it over a period of time to establish beyond the shadow of a doubt. Because remember, you're going to present your findings in chapter 4, and you're going to draw conclusions, right, based on those findings. So you have to do the thing. You have to repeat it a couple of times, right? You might not do like how I drill my students and tell them, hey, look, run it quiet, leave it running all weekend, or leave it running for 7 days, and let's observe the thing. But the point I'm making is don't just do 1 or 2 trials, right? Do it over a period of time. Do it quite a number of times so that you can establish beyond get a comfort level that there is a relationship. And probably from another discussion, right, because I'm just looking at the time that has gone, we could talk about discrete versus continuous variables. And those of you who have done like SPSS or a course in statistical analysis will know this. I remember when I was doing my master's, I had to go through quite a lot, up in Canada, quite a lot of these. So there are quite a, variables can be continuous, that's meaning that there's no gap between them, right? So you could measure, for instance, 7, between 7 and 8, you have an infinite set of numbers. You could have 7.5, or you could get smaller, 7.1, 7.111, and so on ad infinitum, right? As opposed to discrete, right? Where, some discrete values would be, for instance, the set of the months of the year, right? There's no, and if I were to write a program, right, and coding each month of the year as a number, right, then January probably would be 1, and February 2, and so on. Those of you who are into the C-type programming would probably number January as 0, but that's for another day, right? So the thing is, if we have January as 1 and February as 2 and March as 3, those values are discrete. There's no subset. There's no 1.5. You follow? There's no month. There's no 1.5, because that would indicate that there's a sub-month between January and February. All right. So so you have to look again at the type of data that you're measuring. Is it continuous data or discrete data? Also, what are the scales of measurement? So you could look at things like nominal scale, or ordinal scale, or interval scale, or a ratio scale. And I could go in and define what those are, right? But for time, just to say in a nutshell that, all right, a nominal scale would be like gender and color, right? Male, female, or black, white, red, green, and so on, right? Ordinal, data is in categories, like first quarter, second quarter, and so on. Interval scale, yet you have data in categories again, but the interval has meaning, and we don't have a true 0 like IQ or the temperature scale or so on, right? You have a ratio scale, which also limits the data to categories, but the order matters, and the interval has meaning, right? So notice before with the other one, like black, white, red, green, they unless you're into programming, you know that there were some values given for the colors, but seriously, in general life, red, green, yellow, blue, black, white, orange, purple, those are discrete values that there's no order, right? Does black come before green or green come before black? The interval doesn't have any meaning, and the order, right, is not indicated. However, right, with things like length and age, there's an order, right, and intervals have meaning. So you can say you are 43. You know, when you were younger, you remember you were saying, oh, I'm 16 and a half, or I'm almost 17 years old, right? Yeah. And then after you pass 40, you just seem to be perpetually 16, right, Miss Muir? Right. Always looking young. But like things like age and length, right? It has order. So somebody who is 40 years old is older than somebody who is 30, right? And you can have intervals between. So you can say 30.5, 30.25, and so on. All right. Now, some of the other things you see, um, all right, I said I was wrapping up. Things like validity, right, which deals with the accuracy of the measurement, and reliability, um, you know, like the repeatability of the measurement. So there's something we call internal validity and external validity, and so on. You know, I could go on and on, but I'll cut it right there for measurement and talk about sampling. A lot of times you see the population, you need to study the data from the population. Now the population represents the whole, right? So the population of Jamaica is literally every single person in Jamaica. But if they want to do a survey of the population to find out, for instance, if after Queen Elizabeth dies, should we maintain the monarchy, right? If you're going to get the point of view of Jamaicans in general, right? You might want to look at the population by asking every single Jamaican, right, alive on the island, right? You go from Negril Point to Morant Point, you go at the top of Blue Mountain, you go everywhere you find a Jamaican, but that might not be practical. So what we do is we look at just a sample of the population. A sample is just a subset. That's all it means. However, they talk about representative sample because you can go to just one cohort of persons, right? And that cohort might not necessarily reflect the views of that specific cohort, might not represent the views of the wider population. So the way you select your sample, right? And what we find is, and again, when I notice skit research over the years, when the students deal with samples, they tend to use what is known as a convenient sample. So they go and give out they use Survey Monkey or Google Forms, and they send it out to friends and colleagues, or they go under the skit gazebo and hand out the forms, and they go over Fells, which is right close to skit, and they say, oh, see, we have 50 responses, or we have 100 responses, but it's a convenient sample. It doesn't, you see, a representative sample is usually randomly chosen, right? And if you know the whole data, right, stochastic, as opposed to non-deterministic and so on, right? A random sample has a will give you a better representation of the population. And we could go into the science behind that. Things like the Bernoulli child, scientists and mathematicians of yesteryear found that if you throw a dice or a die, right? We say dice in Jamaica, right? One is a die. If I throw it to see 3 times, right? I might be lucky enough every time I throw it to get a 1, right? But there's something called the law of big numbers. That doesn't mean that the die, right, is unfair, or the die is set so that, oh, if I throw it the 4th time, I must get a 1, right? It might just be a lucky go. I had a lucky run, right? But what happened now is if you throw the die over a large number of times, what you'll notice is that every single number on the face of the die, right, will give a true representation, right, of the probability of that thing occurring. So for instance, if I were to toss a coin, the probability of getting heads or tails should be 50, right? Because you have two, and I could go into the maths and the science behind it, but time, right? But in a nutshell, use the coin over the die, since you only have 2 possible outcomes, right? Either you get heads or tails, right? Now, what happened? One of those, what's the probability of getting heads, right? It's 1 out of 2. So it is a half, right? And if it is a fair die, the probability of getting tails should also be a half. When you add up the two, it should come back to the whole, which is one, which is 2 out of 2, right? Now, which is 1. Now, what happened is that if I go and toss the die, or if I ask Mr. Thomas or Miss Muir right now, or Miss Delissa to toss a coin, right? They might have a good run and get heads each time. And you might say, oh, all right. And you come to a conclusion. If I toss the die on the next round, then I definitely am going to get heads, right? But as I said, it might be due, right, to just choice. And what you have to do now is to toss it randomly for quite and usually over a large period of trials. And then now you start to get a true reflection, right? So sampling, right, is used to make conclusions about the entire population. And you could have probability sampling or random sampling. I have non-probability sampling, and it gets into all kind of other subcategories like systematic and stratified and cluster. You remember the late great Carl Stone, right? He was pretty good at doing, cluster sampling and stratified, because, there are enclaves and so on, right? And you have to look at your sample in such a way as to get a true representation of even the minorities and the subgroupings. All right. So experimental research, right? You should have good validity, right? Keep factors other than the treatment constant, so you don't have something called confounding variables. I remember Vanessa Tennant and Opal Donaldson, when they were doing their research, right? Their supervisor came from over UE, and he kept on drilling that home, right? Must have good internal validity, right? And it can be improved, right? They used to meet in the conference room, and I used to go in there because I was so enthused at research. I wanted to hear what their professor from over UE was saying, and he was always there. Miss Donaldson, Miss Tennant, right? You need to go for improve your internal validity, right? By keeping factors other than the treatment constant. So you have these things called confounding variables. You don't want them to go, like when you're doing an experiment in the lab, you can contaminate, right, the sample that you think. So you should wash out your beaker and your bun and the instruments that you're using. When a doctor is performing an operation, they sanitize first, everything. The hands, the gloves, everything. I was about to say utensils, but they call it sharps and so on. Everything that they're going to use on the patient, they sanitize, so that they don't introduce any external things like germs and bacteria and so on, right? Fungus into the wound that they're working on. It's the same thing with our experiment. We should sanitize it, for want of a better word, so we don't introduce what we call confounding variables, right? You have to keep the factors other than the treatment constant. You might want to have even a control group, right? A random assignment of subjects to groups, right? We could go into the whole experimental design, right? Quasi experimental and true experimental. You could have like you could have a pre-treatment, right? Pre-experimental design. You could have like what is called a pre-test and a post-test, right? As opposed to just the treatment and the observation. I remember I spoke earlier about the dependent and the independent variables, right? You could use like a Solomon 4 group design. You might want to look that up. You could look at things like time series experiments or factorial experimental designs, right? And I could go on and on. Like survey research. Survey seems to be popular. But I know Miss Muir spoke about that sometimes, so I won't go over that. Other than to say that, you should choose your sample carefully, develop the questionnaire, supervise the interviews, examine the process you're going to use to collect the data, ensure that, it is solid, analyze the data and report the findings. And I think I'm going to cut it right there and instead just go quickly, just finalize. I have a few minutes left, so I have about 4 minutes, just to look at the actual research that I did, that I supervised, right? So this was the pothole detection one that you saw on TVJ featured. And I'm going to show you how they did their, 1 second, Susan. right, if you see my screen, gonna look at how they did the research design. Yeah, if you see my screen, this is an actual video. I don't know if you are hearing it, right? So that was me and the students. Are you hearing the screen? I probably have to plug this out for you to hear. Right. So the students actually came and I drove them around from Cherry Gardens to, hold on, where is it? Right, that's the device that the prototype they had. See, they're connected to the laptop in the car. They were looking at my car camera and also the camera that they hook up to the front of my car. And we drove around and we did this quite a number of weekends, right? And collected quite a lot of data. And is it? Okay. All right. So, if you see my screen, I'm not sharing. Just give me a second. All right. So if you see my screen, colleagues, this research was done by Tuani Morgan, Denzel Williams, Christine Blackwood, Sasha Moy Palmer, and Romero Brumfield, who are all graduates now. Some of them got first class, right? And the research was entitled Using AI and IoT, that's the Artificial Intelligence and the Internet of Things, for Autonomous Pothole Detection. And if I just scroll through their presentation, right, to chapter 3, which is what? And I mean, the literature research, remember I spoke earlier, right, about establishing things like, what are you doing now? Basic research or applied research and exploratory and so on. They went through and did a good review of the literature, right? So they established what others had done before and what were some of the hypotheses and formulas out there, right? And then now we were able to use that to our advantage. So, right, so we come to their chapter 3, which is the research design, and what they used was a mixed method approach. It was mostly quantitative, so we did an experimental design, as you just saw me a while ago show with the car, but what they also did was interview persons at the National Works Agency, right? And, and they also looked on the population, right? Just the persons who had to deal with roadworks, right? They were chosen carefully based on discussions with the management of the National Solid Works Agency. And they justified why they made, how they chose the sample and why, right? The research instrument, the field experiment, right? I just want to get down to it. So they defined, for instance, like how they would go and set up the research, the experiment. They define what was a true positive, a false positive, and false negative. They look at the formula. Some equations would use, right, to do the calculations, which we would report on in our findings, right? And we actually, this is really the presentation in the actual thesis document. They spelled out, right? There's the laptop that they use with a Raspberry Pi hooked up with some camera sensors. There's it. They hook it up to the front of my car, right? Can you imagine? So instead of using the camera that's built in my car, what I did was just hook up the camera to it. And as you can see there, I went out and bought a tape measure for them and got things like, you know, equipment to measure the angle and other stuff, right? We hook up some cables, right? And they went through and described the hardware in detail, right, that they use. So they didn't just list the hardware, you know, but they list the model computer, the brand, right? Everything, all the hardware was listed, right? And when we bought it and so on. And then for the software, we did the same thing, right? We use Python and TensorFlow for the AI, OpenCV for the camera. We use PHP and Python to code the app, right? They use HTML in the presentation because we had a little a graphical display. We use Google Maps as opposed to ArcView GIS because we wanted to show where the location was. And they use Amazon Web Service, right, as the to host the Heroku database, right? And they use JavaScript as well, right? Because we were plugging the data live. And then they show now what versions of the API they were using and so on. They show a little model to show how everything fit together. And they describe in detail, right, how we went and set it up, what dates we went out on the road, and so on, right? So, ladies and gentlemen, this project, this group, I chose this group because they got the highest mark out of all my major projects last year, right? So that in a nutshell is how you conduct research methodology. You remember again, I'll end just how I started, right? The research methods chapter 3, right? Basically is a look at what kind of research methods you're going to use, right? The specific procedures you're going to employ to conduct that research. You're going to detail the format for presenting the results. And you're going to also list out the resources that you use and how they were used, right? So things like the version number and so on. If you're doing software, so you also want to look at the software artifacts, so things like some of the functional elements as opposed to the non-functional elements, right? And finally, you should do a summary. Ladies and gentlemen, thank you for listening. And that, in essence, is my presentation. If you have any questions, feel free to ask. And thanks, right? I ended 10 under that. So thanks for listening patiently. And I'm opening up to questions. And thanks again, Ms. Shaw, for inviting me.
Good day, Mr. White. Can you hear me? Yeah. Mr.
Yes.
White, I think I'm the one who invited you, but yeah, you're welcome for the invitation.
Oh, I said Dr. Shaw. Sorry. Thanks, Ms. Muir.
No problem. Mr. Logan had brought this up last week. Let's start at the end. In terms of Mrs. Elizabeth, congratulating you for your presentation.
Thank you, Mrs.
When we create a software artifact, is it necessary to describe the approach to the development in the write-up?
I would think so. Again, you see, it depends exactly on what the outcome is. So if, for instance, the focus is on the app you are developing, right? So you're developing a website to show what jobs are available for SCIT students based on their specialization. And you probably want them to put in some criteria, like what their like is, are they maths-based, are they analytical, and so on, and then you want to come up, then yes, you're going to have to describe that software in detail and look at the internal algorithm that's driving the final decision-making process. If you're looking at something that really has to interact with persons a lot, then you're also going to want to explore the drill down on the software artifact to look at like the interface design. What are the, there are some criteria for determining if a piece of software is of good quality, right? And those of you who have studied software quality and software engineering would know them, right? So things like the user interface design, the usability features, right? You have functional and non-functional requirements. How well is there a match between the requirements as stated, right, as you had stated in your original design, and the final output? And how are you going to measure that you have achieved the goals you said you were going to achieve? So you said, for instance, there would be such and such an option. It should be able to do X, Y, Z, right? How are you going to measure that you indeed, right, met those requirements? And then again, as I said, if the focus is really on the output, the piece of software that you're developing, you might also want to look at things like, also related to software quality, would be the reliability of that software. So you want to show like your test cases. How did you design your test cases to show that the software always works? It always does what it's supposed to do. So you don't just do a little one piece of demonstration and said, yes, see, it works. But you do a detailed design. You don't want to go like, look at the edge cases, right? Those also are into programming, like your loops, right? What happened if you put, if you run the loop to its end, what happened at the edge case? Does it run one time more or does it run one time less? And then for numerical data, you also want to test it with things like what happened. So you're supposed to put in your age in the example I just mentioned a while ago, right? Probably you want to put in your age and your specialization and so on. What happened if I type in, if Susan is running it and Susan types in sweet 16, right? Instead of typing her age, it's a number. Would the program crash, right? A lot of times we're doing presentations, you see, and also I remember when I used to teach like programming too, and the students come before us to demonstrate their projects, and they say, I said, guys, does it work, right? I always start with that, and I say, yes, sir, we have tested it, much hours and sleepless night. I say, okay, all right. And I was putting a few nonsense values and immediately it crashes or it goes into an endless loop. And they're like, sir, what did you do? Right? And I'm like, you know what I started doing? I started saying, all right, I'm not going to touch it. Right? You type in the data, right? Even in the intelligence lab, systems lab, when people come and say, oh yeah, man, this, I say, guys, remember, we have a certain quality that we have to demonstrate. So I said, look now, put in there as the age minus 99999. Right? What does it do? A good piece of software would capture that data. Those are the software, exception handling is a thing. So you should it should capture that error. It shouldn't display any error, it shouldn't crash. It shouldn't go into any endless loop. It should sanitize the data, right? And show me some message that says, I'm sorry, you are only supposed to put in numerical values, or I'm sorry, the range that you should put in, or I'm sorry, you can only select, right, information systems or networking or whatever. In fact, even better design would be not to allow the user to type, right, but to allow the user to select the data from a menu or so on. So there's less possibility of making a mistake. But then it can get it's not suited for all kind of data because it can get real tedious and it can be counterproductive. If, for instance, you're asking the user to enter a date, say, right, or the grandparents' date of birth, right, and then their date, and you give them, because you don't want them to type in erroneous data or nonsense data, you use a slider or you use a selection. You know, like a tool where they can't type in the date, they have to select it from the calendar, and then their grandmother was born in 1938. Right? You can imagine it starts at the current date and you have to really click next or back all the way back to 1938. The user will get frustrated, right? So again, it depends on what you're doing. But thanks for that question, Ms. Mira. Right? If however though, the focus isn't on the software but on something else, like in my case, my project last year, the focus wasn't on just building a piece of software, it was on detecting potholes, right? So the software was just one link, right, towards getting more accurate identification of the potholes and logging it so that the NWA could do their work. Also, I see, colleagues, you should also notice that there are sometimes black boxes, right, which you don't have. You don't have the liberty, right, of describing what is happening in those black boxes. And you have software and hardware black boxes. So you might have somebody doing like what my group did with the temperature sensor, and we bought our own sensor and built it. We bought the Raspberry Pi, right? We bought Arduinos, we bought our resistors, we bought the cables, and we bought a breadboard. And thanks to Carleen Blackage, Miss Black actually, she had a 3D printer in the animation. She printed the first, she printed the prototype for us, right? The box to put it in. And then Mr. Ray Williams, who is head of the surgical lab, he later on came on board and bought some other stuff and donated to us. Now, we now had to describe, we are going to have to describe our makeup, how we write the software to interface with those cameras and the sensors, and how we actually put the thing together. Take another group now. Remember the group last year that I had, the one that did develop the system to detect when trailer drivers were falling asleep around the wheel? So if you're driving from Kingston to Montego Bay, carrying cement or so on, right? And you know, the road long and tedious and boring, right? The driver might be falling asleep. A lot of them drive at night. So we had a sensor. We had a system that detected if the driver was falling asleep, and immediately hook up to the car radio, it would blast something and wake up the driver to tell him, hey, you're running off the road. Now, what that group did, rather than build every single thing from scratch, we actually bought a module, right, where the camera was integrated, right, with some other devices. So, of course, we didn't have that was a black box. We didn't have the benefit of design, of detailing the internal circuitry for that. We could understand how we put them together. You follow? But whatever you do, you should, as much as possible, detail what the component parts are, whether it is hardware or software, what is the process of putting it together, what's the formula that you use, right? The rationale, the mechanisms, right? And how it works, the internal working as best as you can, so that somebody can. Remember, I spoke about the replicability, right? Research must be repeatable. So if Dr. Shaw were to look at this, or Ms. Delissa were to say, hey, I like this, let us look at it. And call Mr. Logan and say, all right, let's get the components, right? And ask Mr. Thomas to go through in detail the research methods that you outlined. They should be able to repeat the research that you did and get pretty much the same results, right? Or similar results, right? So they can arrive at the same conclusion you did and say, this was research well done.
Thank you, Mr. White. But when you just said, remember a project I'd never heard about until just now, I didn't remember. That is why I'm going to make a charge. I've said to Mr. White, I'm saying to all people, Mr. White, most likely that project could at least have been a lessons learned project, if not even a presentation at a conference or a journal paper. I don't know, since I don't know about it. So colleagues, we all need to be writing papers about what we're doing. So I didn't happen to be in that major project presentation, and I didn't know about that project. It sounds very interesting. And so this is the kind of thing that is potentially publishable. So we need to publish.
Sorry, I thought everybody knew about it. But just remember, their pothole one and the temperature sensor were featured on TVJ. They clean up.
And what I knew about them when I was in meetings where you showed it. I didn't have to watch the TV when it was that. So when I've been in other meetings where you showed, that's when I knew about those projects. But that's not the point. I'm making a bigger point.
I agree with you.
The bigger point is we need to be looking, and as I was saying to you, I've been said to you for a whole year. We can even look at those projects to see if there's anything that's in those projects that can be publishable. And I don't know if you all agree with me, I think it's just with practical projects, it makes more sense to continue the project in year 2 if you've made some progress, but not enough to do something useful, than to move on to a new topic, just to look at topics for topic's sake, in my opinion, I don't know what you all think, is of limited value. I mean, it's a good experience for the students, but perhaps the charge for universities is to, where possible, especially in a developing country, deal with things that can solve problems, as the applied research that you're focusing on, Mr. White. So the way to do that, I think, is to, where possible, publish or continue the project until we actually have something that can be of clear practical significance. But that's just a little.
Agreed.
I did have another question, but I also want to make a short presentation. But let me ask the colleagues if you have any comment or a question based on what Mr. White has presented so far today. Thank you very much for an interesting presentation. No questions?
I have a question here. Good. Based on your point, we don't need to be told to publish paper, because what pays us is the hours we teach. Pays us, but what promotes us is papers we publish. Now, my question now is, how do we fund these papers? Because
what do we what? Fund research?
How do we fund these papers? You get the papers. How do you fund their publications? How do you fund their publication? It's unfortunate because now we are online. Maybe we can deliver online. What if you have to travel to any nearby country here? Travel just to next Caribbean country to present. Their cases ordinary to go and present TVET that is doing in Montego Bay. They will tell you there's no money. So how do we fund this paper? That's most important.
I can answer that, Mr. Diego. I'll put on my even though I'm not in senior management, I can answer that partly. UTech papers. UTech funds, hold on, I'm answering you. UTech funds papers, UTech currently has a very poor model for funding conferences. So if you, at the end of it, UTech currently, the Research Development Fund even has money for papers that cost money to publish. So if you write a paper that's accepted, they will give you the money up to quite a bit of high money. Sorry, not in the top tier journals, but they give you money to publish papers. They will give you an incentive. I don't remember the amount. Plus, they actually, if the journal costs money, they give you that money. I personally believe that it's probably a better model to go to conferences before you try to publish journal papers. And that is where UTech has limited money. So they basically either want you to either use your book grant, which we all know is very limited, or to appeal to the faculty to ask for money. So, but at the end of it, currently, UTech is focusing on journals. So even though they just ask it to please give them a list of conferences we attended, the goal is to essentially, universities are measured based on the papers more than anything that people publish. So UTech's model is focused only on that. So remember, I'm not the head of school, I'm not the dean, I'm just giving you the current UTech current answer. So I personally think that we could definitely go a much further way in terms of helping people for conferences, because there needs to be a way to step from baby steps to big steps. And conferences are big steps.
We understand you are not head of school or anything, but you ask us to publish. I'm just trying to let you know the barriers we have. Then the question is,
but as I said, there is
can you help
a
us?
pathway, but there is a pathway for journals.
That's what if we have alternative plan to get out of these barriers.
Yeah, but you can get papers. And in fact, on that note too, I presented at a conference and I just wanted to test it out. And I sent to Dr. Ivy, who is the head of the graduate research and entrepreneurship unit, and a proposal to convert a conference paper into a journal. I was a little bit surprised that I actually got accepted, but what I was dismayed about, that they gave me about, I don't know exactly now, about a third of what I asked for. And I basically have not yet decided, it's been months. That was about October of last year. I have not yet decided to use it because basically the amount of money they're giving me for a research assistant to help me, it's just not worth it to me. So I haven't gotten the time to write the paper yet. And so I agree with you. But what I do know is that if you get to the point where your journal article is ready, or if it's a conference that the dean approves of and there's still money in the budget, you can get partial representation. Anyway, back to, is there any question about Mr. White's presentation?
Right. Ms. Muir, Mr.
Yes?
Could just respond to something Mr. Logan wrote.
Sure, go ahead.
I want to just commend Mr. Christopher Odega though, as one of the persons. I was looking at something. We were working on the red document over the weekend, and last week, you know, Ms. Delisa is putting it together. And one question we had to come up with was how the research output from the school over the years from 2014. And unfortunately, that is one area where we're not doing so well. Just a few persons have been doing the bulk of the publications, right? And you know some of them here, like yourself, Mrs. McNamara, Dr. Shaw, Professor Top. But Christopher Odega is one of those persons who has been publishing, and not just publishing by himself, but he also has been publishing with his students. I saw his articles a couple of times in the IEEE, so I just want to take my hat off to Mr. Odega and commend him, right? Because he has been practicing what we have been saying and what you just said, Ms. Muir, and I want to follow his footsteps, right, to publish my major projects. Mr. Logan, that comment you say about the software and so on, thanks for that, sir. And I just want to share something else with you quickly. Sometimes you see, if the students take time out and do a good methodology, they make the project very, very easier to do. The end goal is in sight. We have this joke in the lab where we say, can you see the end? So we say, look, fast forward, it's July 6th, it's final Viva, right? And you're up there doing the presentation, right? Do you see yourself, based on your research design that you just outlined, do you see yourself being able to answer the research questions? And if so, if not, then come back and make us go over the research design. And let me tell you something, with that project I highlighted a while ago, one of them, the pothole one, persons were telling them, right, guys, you need to go out there and go do a survey to ask students and the general public how they feel about potholes and so on. Because you see, it tends, I'm sorry, but it tends to show like the students not sure them project. And so, like an overachiever, so you're trying to just add on more and more and more. And it's overkill. And sometimes, like somebody doing an exam and they write the answer and the answer is correct, but they're not sure that it's correct. So they add on more to the answer and they change what was already a right answer into a wrong answer. Because when they add on the stuff to it now, it invalidates some of what they wrote in the right answer. I'm sure all of we as lecturers have seen that before when you're marking exam papers. Same thing with research methods. So you know what I told that pothole group? I said, no, do not do a thing more, right? What you want to do, remember what we're trying to do. We're trying to see if we could find potholes easier for the government, right? And identify where those potholes are. I want to show the accuracy. We have a time frame that we got from the National Works Agency. And so I went out to the hardware store and bought a tape measure. And those weekends, week after week, we met every single week, Friday, right, for over a 1 year period. And I said to them, guys, once you had all the data and we were armed with the formulas and everything, the literature review, we went out there now and measured like the angle at which we put the camera on the car. But we did a whole heap of measurements, but that was enough. So we measure how far away the pothole had to be, right? If I had time and play the other videos for you, or if you saw it on TV, right? We measured like how close you had to be to the pothole before they detect it. And what was the furthest away you could be, right? Then they asked me to speed up, right? So I drove like at different intervals. I drove like at 5 miles per hour. I drove at 15, at 30, and then I drove very fast. You should see me down Oak Pastors, behind UTech, on Garden Town Road. We went up in Cherry Gardens and so on, right? And we did quite a lot. Then we measured what was the time of day. Did we get the same figures in the morning as we did in the evening? What happened when it was cloudy, right? And we measured the angle. We put the camera on different parts of my car. We put it on top, we put it on the bonnet, we put it on the dashboard from inside, right? We put it on the mirror, on the outside mirror, right? The side mirror. We tape it on and so on. And we got different measurements until we came up now with what was the ideal placement. For the one with the sleep detection system, that one didn't come on TV.
Mr. White, 1 second.
Right.
I want to finish at 10:30 and I want to make a short presentation. And people, even like the last time, people said, when is it going to end? So this would, and some of this needs a discussion. So if you don't mind, we could do that after this, if there's some time, if you don't mind. So colleagues, this is going to be very short. So giving you an invitation to summer research. What we've been doing, this is week 4, is a series of presentations and interactive workshops on upskilling major project supervisors. I'm thinking for next week, since we're doing it once per week, that we could do it on Wednesday. And I wanted to have a discussion of what time would be good, if that would be good for those who are here. I can't see what's in the chat on this side. Make my screen smaller. How am I going to see what's in the chat? Oh, okay. So Mrs. McNamara is saying that we should continue. All right. Yes. So could we do this next week, Wednesday instead? Could it be later than 9 o'clock? Because I find this early morning thing to be challenging for me because I've been charged. I have to get going early. We're going to do, as you may not have known, Dr. Faisal, I have got accepted or abstract for a journal paper relating to the training of students and staff in SCIT. We're going to be doing a research project, and as such, we're going to start the the goal is to start the preliminary evaluation of this process next week. So we have a survey that we'd like to issue at the end of the training next week. That's the tentative goal. As part of the research process, so we're researching or training our researchers. And I am just inviting, what topic would you like us to look at next? I know last week Mr. Logan had said that he wanted a presentation. I had said I was going to look at, thank you. I was going to look at mixed methods today, but we're out of time, and I decided to put it off. And he said he wanted to look at comparison between when do you do qualitative versus mixed methods versus quantitative, and that was one request, and we can do that next week. Just want to know now, is there anything? The goal is to keep going through each of the chapters. So eventually, obviously, we get to chapter 4 and chapter 5. But since we're here discussing, is there anything specific anybody wants help or presentation about? This is, I'm opening the floor for comment or question. No comment? So if we said that the next session was next week, Wednesday, I'm not sure, is 10 a.m. or 1 p.m.? What's a good time for everybody? Okay, while you're thinking about it, should I move on to the next? Or is it that you guys like Monday at 9 a.m.?
Susan.
Yes, right?
Can we just go through all the chapters first? So making sure we finish chapters 1 to 5, and then we can do the sub things after.
Yeah, but the sub things are all to do with each of the chapters.
Yeah.
What do you mean by the sub things? So for example, what we've now basically spent is 2 weeks on chapter 3. Basically, if I continue on to, because we really haven't talked about mixed methods yet, it's basically chapter 3 when you have mixed methods. It really is, do we want to move to chapter 4? So I'm basically asking, so Mr. Thomas thinks we need to go to chapter 4 next week, which you can. Anybody else?
No, we can't do the mixed methods.
Any other thoughts, guys? Because my thought right now is we go to mixed methods next week, and then the week after that we go to chapter 4, and the week after that we go to chapter 5. I mean,
Yeah,
we actually need to spend more than 1 week on chapter 4 because chapter 4 is quite complex. So initially when we said 1 week per chapter,
it was a guide.
It was a guide. And as we're going on, this is the first time we're doing it. I'm actually thinking we could do this every year or as needed. So we're basically doing it as we go along to see what works. So I'm proposing Wednesday. Is there any specific preferred time?
I don't. Why are you changing the day? I think.
Well, I could say with Monday, but the 9 o'clock is not working for me. So it's really early. And a lot of times I'm presenting and I need to get going before 9. It's really tricky for me. So if you guys like Monday, what about 10 or 11?
I like the Monday at 9 because we just get it done and we're over, and then.
Okay, well, is everybody like Mrs. Mack prefers the Monday at 9? No, if everybody likes Monday at 9, we'll continue with Monday at 9.
That works for me.
Okay. So I'm the only person who doesn't like. Oh, everybody like the Monday. Okay, so we'll continue Monday at 9 then, since that works. Well, it just means I had to get up early.
Suzanne?
Yes?
Going back to that previous discussion, when do we expect to complete the workshop? Because that does have a bearing on how we do the different chapters.
Well, if let's just focus on, at the moment, this is focusing on major project, and people who are not supervising major project can obviously come. Major project V for this year is July 6th or some date like that, the first Tuesday in July. So it's going to finish whenever it's finished. So given that we're in the first week of May, at the rate we're going, I expect it to finish in May.
Okay.
But the latest June at the rate we're going. So it's whenever it's finished. I don't have a set date for it to finish.
Okay. But I would imagine that you'd want it to finish in time to provide advice to students who are going to present in July. So probably end of May, first week of June.
Right, but that goes straight to, let's go to straight to which one? So there are two different, the thing about it, anything we do here, given that, let me just go with my opinion. My opinion, I could be wrong, it's going to take more than a few sessions to have, and make it worse, as Mr. Mack said it last week, some persons who probably need the help more have not come to one session. Maybe they'll take the opportunity to watch the YouTube videos when they're sent out to the wider group. But I find this as an iterative process. So I can say to any of my colleagues, can you please just look at this part of the major project? I have some concerns. I think what we really should be doing, as I said, from the first week, is to find ways to partner together to take a look at each other's major projects, so that we're to solely supervise a major project. Unless you've had a PhD and possibly done many projects, and even you've done a PhD and many projects, you can have a blind eye to something that's missing in your project. So I see this whole thing as not just let's learn through a formal workshop setting, let's find ways to partner with each other so that we can lift the quality of major projects. That's what I'm based on everything I've learned going forward. I mean, maybe it's because I'm now in these ministerial health research groups and see the how in practice group research, because I'm in two of them, group research can actually lead to higher quality output. I mean, there's another problem. If the group is too big, then you have some of it just wasting time because the group is too big. But once the group is not too big, so that's my two cents. But yes, I think we can attempt to finish in May. And for those who have been attending, that would provide the basis of them giving better feedback than they've been giving before. So, I actually have, in fact, maybe I should go here first. So I was wanting to talk about two things. So the upskilling of major project for students, so being for staffs, starts this week. So my goal is to, I've been having it anyway, but very informally. I'm having a large group workshop every Wednesday, 5 to 7 for basically major project students, not just the ones that I supervise. And basically, the goal is to go through this eventually, since in the end of July, there'll be a post and paper competition and we have intervention. So right now, the ethics committee should be meeting this week on Thursday. Dr. Fisher, do you know what time it's meeting? Because I haven't seen the email invitation.
I'm not sure if it gets the regular 10 a.m. time.
Okay, right. So there's still some groups based on where they are. I think they haven't even submitted ethics, or if they submitted ethics, is still weak. So I expect ethics to be looked at, and there actually perhaps maybe a need for mini viva, because there are some groups that did not do the mini viva and some that did the mini viva that did not do it well. I don't know about organizing it formally, but these are the things that I see as part of the upskilling major projects, and that starts this Wednesday. I've already started, but I'm going to start it formally this Wednesday. So let's go to where I am. So right now, my goal is to have two things this summer. One is to have for the third year students, as in students who are not doing major projects yet, undergraduate research experience, which, by the way, there's a lot of literature on undergraduate research experience in the sciences. I haven't seen, I could look for it. I haven't noticed any on computing in particular, but one of the best groups I had this semester for computing research methods did a proposal for work readiness of, this is not their exact title, but this is what I'm tentatively recalling it. Work readiness of computing undergraduate students, perceptions of employees and students. And I thought it was, I think it's both a relevant project and something worth doing. And I'm thinking that this is something we could actually do as a group. And at the moment, so I'm thinking of basically doing some research studies this summer with students, helping collecting the data and understanding the whole process. And I'm inviting colleagues to want to help with this whole process, which is, none of these would be major project per se, just research. So for those who want to publish, we can form these groups up. So Mrs. McNamara would know about this already. So there's a help project. So Mrs. McNamara and myself is in a working committee for computer modeling. And you may or may not know, colleagues, that the youth, adolescents, and young adults up to about 30 are actually, based on the empirical data right now, are the persons with the highest percentage of success. Sorry, I'm not saying it right. The highest amount of COVID cases are actually people who are young, but they don't die or are hospitalized. So because they have COVID and they actually have the highest percentage of what's it called? Symptoms, most likely the people who are spreading the disease in Jamaica is the young people. So based on that, the group basically suggested that, can we find a way to have youth look at essentially simple computer models to show that this is really a problem. So in that meeting recently, I volunteered and said that this is something we could look at UTech in this project, in this summer thing going forward. So I'm inviting all of you to be involved. I'm actually thinking that these projects will happen starting in June, because I talked to the third years that I teach, and they all want a break, which all makes sense to me. So sometime in June, we would start these kind of projects. And then I had a question, maybe there could be a third project. That's only if there's enough support by staff and students. So we have to figure out which of these are really possible, because we don't want to do too many. So clearly there could be a computer science project. I know that, sorry, Mr. White has a master project, part of his intelligent systems lab. That's really complex. So I don't know if that could be considered part of this. I don't know, but he has a quite ambitious project that he's doing independent of major project. And clearly we have a lot of interest in our school in computers and education. So perhaps this could be something that we let in the students help us with the data collection and experience. So this needs to be worked out, but that's my thinking for the summer. And the aim is to have the students and staff have experience of well-conceived research studies to publish this year, and to prepare people who come to this for good major projects. And if, since we can also invite other people, for people who are even graduated or graduating, they can be prepared for other research projects. And the third years would be, based on this experience, have a good idea how to start their concept papers, because Mrs. Delissa had the very sensible idea to suggest that we start major projects in the summer if possible. So we want as many students to prepare their concept paper. That is basically the chapter 1, the concept paper plus a little synopsis of what they consider to be the methods as early as possible, so we don't have this rush at the end for people to try to finish major project in the last 2 months of the year. That's what's been happening for quite a while now. And then I already said that this is what would be going on for major project students starting this Wednesday. So I want to have, since I'm having a Wednesday thing every single Wednesday, I want to have a formal lunch. So if you remember, this is academic, awesome stands for academic writing experience, supervisor and student, upskilling, mentoring experience, and CURE is for computer undergraduate research experience. So this will be May going forward for the students. This is for June going forward for students. And I'm going to send out a Zoom link soon. And SCIT staff and students are welcome. So I'm inviting you to be both a student and supervisor of research. Any questions or comments?
Yes, Ms. Mira. Sophia McNamara and Stephen Scale. Mr. Scale says you would like to work, and Ms. Max says you'd like to ask them.
Mr. Scale said he'd like to work, and Mrs. Mack said what?
She has her hand up.
Okay, go ahead, Mrs. Mack.
I just want to be clear. One is, so the student research experience, the idea is that students would actually work on some research project. Is that it?
Yes.
Okay. During the
Right.
summer, the third years.
Right, the third years. So, like, if you go back to where I had the list.
Right.
This.
Projects, but they're not.
Projects.
They're, oh, the first one is clearly defined.
Yeah, and this one, actually, this one you know. So the second one is actually fairly clearly defined yet. But since I haven't even seen the software, all of that.
But what would you make them do with the software? Just what was it? What was?
I think we're a little bit out of time, but I can just explain what I'm thinking. There are many different possibilities. What I'm actually thinking is it could be two different kinds of things. So one could be just an experience for the students. So I'm thinking of an
experience. What would the experience?
I'm answering you. I actually would prefer for this to be the people who, no, let me just talk it through. Okay, so here's what I'm thinking. So there's a model that's a free software model or a free software tool online. In fact, there are others as well that can apparently be used to, here you have this empirical data, you do basically what if analysis. So the students would have exposure to that tool. And I think, based on my understanding of that meeting, the goal would be for those students to use a software tool to understand what's happening with real epidemiological data, with the goal for them to perhaps tell other persons, whether online or in person, I guess really online given it's COVID-19, that this thing is serious. We need to actually follow the health protocols because we are the people, the young people are really, because they're going with the data. So that's one part of it. It's sort of like our working group. It's more about sort of like using software for things that's relevant to society. It's hold on.
The research?
So I don't know what the only research I have in mind, and that's why the research I have in mind is that we could do a research project to see if the students who use that actually change their attitudes and behavior.
Oh, all right.
I actually thought of that, but I don't think that every single thing that students do have to be necessarily that they're doing research. And if I go to a friend of mine who's a full professor who has many published research, he says that we should not be over ambitious on what we give students as the first experience.
Okay.
What I'm hoping is that if people come on board, we can, and the problem is if it take what's happening right here, all I'm hearing is that Mrs. McNamara and Stephen Scale is interested. I actually know that maybe there are 2 or 3 others. These things will not work with just Suzanne Muir and 3 other lecturers. For this to work really well, we need preferably at least a third of staff to say, yes, this is so exciting. Or no, we have better project in mind, Suzanne. We don't think this is so exciting. Let's do something else. But if we don't decide that this is what we're doing and taking this whole thing seriously, it won't happen. It has to be a concerted effort for this to happen well. Does that answer your question, Mrs. Mack?
Yeah, I'm good. I was trying to figure out what would be the research aspect, but I got it. I see what could be possible.
Okay.
And Dr. Shaw is trying to come in, Ms. Miller.
Go ahead, Dr. Shaw.
Right. I just wanted to remind you that there are several research groups as well.
Yes, I know.
So for example, for the Computing Education Research Group, we have several persons who have indicated that they too would want to, or they are committing to embarking on and completing, and you're a part of that group too, so you're aware, committing to completing some projects by the end of this summer. I mean, what we really want is for the entire school to be involved in this effort. And so, it's complementing what's being done here. And we do invite people who would want to, join in on some of the research activities that we're doing, or as you said, if they're already doing, some things. I know Mr. White, for example, with his groups, we want to see those papers coming out of his groups. So I think ultimately what we want to do is to improve the research capabilities of the school and see those papers, actually bearing fruit.
All right.
McNamara had put in the chat, JAST, the call for JAST is out, right? And we've all done work, I think, that can go in JAST. So we should make at least a submission. There's
So
no harm in doing that.
thanks for that, Dr. Fisher. What I'm really saying here for third project is any of, because you gave me I wasn't able to go to that last meeting. Any of those projects could be a part of, is there a way for the undergraduate students to be involved in one of them? That's the idea here now. It's not to say let's take it over everything for the school. I'm saying is, can we find a way to have exposure of students who are interested, and they all won't be interested, before they do major project, and then we can do presentations, to students at some point. So even ones who weren't involved can say, oh, this is what happened, this is how it works. Students will talk to each other. It's just to improve the quality of research for both staff and students. That's the idea.
All right, noted. I think.
Rach? Yeah, so
Ms. Parks is also putting in her support. She said she wants to be a part of it.
okay, thanks for that. All right. So I get a sub share. So Mr. White is telling me I'm doing a good job. Thanks for that. Right. So based on that, you guys want to continue next week, Monday at 9 o'clock. So next week we will look at mixed methods and qualitative. I just had a quick comment. So my quick comment to what Mr. White had said earlier is it took me two things. Correlational research is not causation research, guys. I know Mr. White sort of inferred that, but I just want to say that clearly. So the fact that those correlations are not causal is because those are correlational research. So correlational research to do causation research, essentially you need to do true experiments. And then the next best is quasi experiments. So Mr. White didn't talk today about experiments, but that's okay because last week Dr. Thorpe talked about experimental studies, and I think that we're not going to have another presentation on that, but just to let you know that that's the reason why there can be these mistakes, because people don't realize that correlational research is not causation research, and not only that. The other thing, just as a note, Mr. White, I see where you're going, but don't forget that it could be both ways. So when you said that science and the suicides, it could be, if you're making a spurious correlation, it could be that because they saw that there's more suicide, they decided to do more research. But just don't forget that the correlation could be both ways. That's exactly why there's so many problems. Unless you actually did an experimental study, and how would you do that? It would be very difficult given all the other confounding factors. But and one other comment, because I misunderstood this for a very long time, colleagues. In fact, longitudinal versus cross-sectional. So longitudinal, to me, my simplest definition is you collect data on some variable twice. It's not just the length, because cross-sectional means you, in my opinion, you collect data on a variable or many variables once. So for example, the National Lifestyle Survey in Jamaica actually took place over more than a year, and it's a cross-sectional study because collecting data was just time consuming. So it's an actual excellent cross-sectional study published every 7 years in multiple journals, but because of how the data is collected, and it costs more than $1 million in Jamaica, and all of what they do, it takes that long to do a cross-sectional study of the health and lifestyle of Jamaicans. If they were going to do a longitudinal study, you would take, by the way, I was a participant. You would take me and measure my health today and come back in 3 months or come back in 6 months or come back whatever day and say, this is the change in me. That's a longitudinal study. And then there are different types of longitudinal studies, so one type of longitudinal study is experimental, but there are other types. You could do observation, you can do cohort. There are many types, case control, etc. Just to augment what Mr. White shared earlier. Any comments or questions?
Thanks for that, Ms. Mary.
Any comments or questions?
Just one quick thing, Suzanne. I mean, just going back to the undergrad research
Mhm.
experience earlier. I think if the students could be invited, well, Mr. White already does it, but for others or even for us for the computer education research group, the students could be invited to be a part of the group itself
Mhm.
and so contribute to the research experience. So, you know, when you do speak with them, especially for this one, we're willing to have the students join us, and then they can be a part of the research experience to assisting in the collection of data and, you know, being part of the publication team.
Okay.
So that too can help.
All right. Yeah, well, that is basically the idea. So the idea is to have something that would be basically that. And I basically said somewhere between 2 to 4 projects. It's just a matter of how to formally figure that out, how it works. But yes, that's the goal. So we're basically finished. So I guess we're meeting again next week, Monday at 9. Guess I'm the only one who doesn't like this 9 o'clock. Yes. All right. So that's it. Thanks very much, everybody, for joining.
Thank you.
Thank you.
Thank you, Susan. As usual, a very rich time.
Very well done.
Okay.
Yes. Thank you.
Thanks, bye.
Okay, good. Bye-bye.
Thanks, Ms. Muir. You have been doing an excellent job. I've never spoken about it before, but I just want to acknowledge that and let it be registered that I think you're doing excellently. Just encourage you to keep it up despite the challenges that it poses for you.
Yes, thank you, Mr. Panther. Well, we're going to do, as I said, we're going to do a formal evaluation. So please make yourself available for the evaluation. Because basically we just want to know how everything is going for everybody. And yes, I'm getting letters. Okay. Interesting. I'm getting a letter from HR in the mail. Yeah, definitely. Let me continue despite the challenges is what I would say. Yeah, man, everybody, thanks for joining. And I guess we'll see you next week, Monday. It's all right. Thank you very much for your presentation. Dr. Fisher and David, we need to organize a time to talk about the rubric.
The rubric.
But I would say, let's not do that immediately.
All right.
We need to do it, but I would say it's not as urgent right now, but we need to do it.
All right. Thank you.
And Lisa, we just need to figure out a time where you and I are going to meet. You said tomorrow. What's a good time tomorrow? Since we're on the call, it's a talk. It's not private.
I think you want them to stop recording since it's still recording.
Yes, because we could stop recording. David, stop recording. Mr. White?
Yeah, sorry, Michelle. You were saying
You're saying we could stop recording.
All right, no problem. All right, the recording has stopped. Let me 1 second.
It's still live on YouTube.
Yes.
I don't think we want this on YouTube.